The universe is vast, mysterious, and brimming with possibilities. For centuries, humanity has wondered, are we alone in the cosmos? As technology advanced, we inched closer to finding an answer. But the launch of the James Webb Space Telescope brought us into a transformative era of discovery. With the JWST's unparalleled capabilities, the search for planets beyond our solar system, exoplanets, has reached new heights. Could one of these distant worlds harbor life? Let's explore the science, the discoveries, and the potential reality of life beyond Earth. The James Webb Space Telescope is humanity's most sophisticated space observatory to date. Often described as the successor to Hubble, the JWST was designed not just to observe distant galaxies, but to uncover the secrets of planetary science, star formation, and more. Unlike the Hubble Space Telescope, which primarily observes invisible and ultraviolet light, the JWST specializes in infrared light. This capability allows it to peer deeper into space and time, capturing the faintest signals from the farthest reaches of the universe. By doing so, it can study the atmospheres of distant exoplanets in detail, a key feature in determining their potential habitability. Envisioned as a collaborative project between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, the telescope represents decades of innovation. Its launch in December 2021 marked the beginning of a new chapter in our cosmic exploration journey. Before diving into the JWST's discoveries, let's understand the importance of exoplanets in the broader search for life. Exoplanets are planets that orbit stars outside our solar system. Until the 1990s, their existence was purely theoretical. The first confirmed detection of an exoplanet ushered in an era of hope and wonder, showing us that planetary systems exist beyond our sun. The Kepler Space Telescope revolutionized this field by identifying thousands of exoplanets during its mission. From dim stars to massive giant planets, Kepler taught us that the galaxy is teeming with diverse worlds. Some orbit close to their stars in extreme heat, while others, like rogue planets, drift through space unattached to any star. Among these discoveries, planets that fall in the so-called habitable zone, a region where liquid water might exist, became the most intriguing targets. And now, with the JWST, we can do more than simply locate planets. We can investigate their chemical compositions and assess their potential to support life. The James Webb Space Telescope has already identified several exoplanets, and its data provide an unprecedented level of detail. These discoveries are truly groundbreaking for planetary science and astrobiology. One remarkable example comes from a star system nearly 40 light-years away, where Webb's instruments detected traces of water vapor in the atmosphere of an exoplanet. Let's break this down. Detecting water vapor is not just about confirming the presence of water, but also understanding atmospheric conditions that might support life. In addition to water, scientists are looking for gases like carbon dioxide, methane, or even oxygen, which could suggest biological activity. It's important to note that not all planets discovered by the JWST are Earth-like. Some are gas giants, while others are rocky with extremely high temperatures. However, this diversity shows us how much we still have to learn about planetary systems and the potential for life in conditions unlike Earth's. What exactly are scientists searching for when they say a planet might be habitable? One of the first criteria is the habitable zone, or Goldilocks zone. This is the area around a star where the temperature is just right, not too hot, not too cold, for liquid water to exist. Without liquid water, as far as we know, the chemistry needed for life cannot occur. But being in this zone is only the beginning. Another factor is the planet's size and composition. Small, rocky planets like Earth are more likely to have solid surfaces and retain atmospheres necessary to nurture life. Planets that are too small might lose their atmospheres, while planets too large could turn into gas giants with crushing pressures. The final and perhaps most revealing consideration is the atmosphere itself. A planet's atmosphere acts as a climate regulator, maintaining surface temperatures within ranges suitable for life. When scientists detect water vapor or gases like methane and oxygen in an exoplanet's atmosphere, it sparks excitement because these chemicals can be linked to biological activity. Studying distant exoplanets is no easy task. These planets are usually located light years away and are often obscured by the glare of their host stars. So, how does JWST do it? One of the telescope's most powerful tools is spectroscopy. When light from a star passes through an exoplanet's atmosphere, the atmosphere absorbs certain wavelengths of light. These absorption patterns act as a fingerprint, allowing scientists to identify the gases present. For instance, if the spectrum reveals water vapor, we know the planet has water in its atmosphere. Similarly, detecting molecules like methane, which can be produced by both geological and biological processes, raises the possibility of life. The ability to analyze such faint signals is part of what makes the JWST revolutionary. Additionally, the telescope uses advanced imaging techniques to block out the light of the host star, isolating the dim glow of the planet. This direct imaging has opened new doors to studying small details like cloud formations or temperature variations on exoplanets. The scientific and philosophical implications of these discoveries are profound. On the scientific front, each new exoplanet discovered by the JWST deepens our understanding of planetary systems. For example, the diversity of exoplanets observed so far underscores the fact that planets can form in environments wildly different from our own solar system. But more exciting is how these findings fit into humanity's quest to find life beyond Earth. The ability to detect key chemical compounds linked to biology means we are closer than ever to identifying planets that may be habitable or even inhabited. One intriguing possibility is the discovery of planets with biosignatures. A biosignature is any feature or substance that provides evidence of life, whether current or ancient. If JWST uncovers more exoplanets with atmospheres rich in compounds like oxygen or methane in the right proportions, the scientific community will have to grapple with the growing likelihood of extraterrestrial life. It's easy to focus on finding Earth-like planets when searching for life. After all, Earth is the only example we have of a world that hosts living organisms. But part of what makes the JWST's mission exciting is that it's challenging our assumptions about life itself. What if life could thrive in conditions vastly different from those on Earth? For instance, scientists have observed microbial life surviving in extreme conditions here on our planet. From boiling hydrothermal vents deep in the oceans to the freezing landscapes of Antarctica, Earth's extremophiles suggest that life might adapt to various environments. Could similar forms of life exist on hot, rocky exoplanets or gaseous worlds with thick clouds? Additionally, there's the question of what alien ecosystems might look like. If photosynthesis, the process through which plants convert light into energy, works differently under a red dwarf star, the dominant plant life may appear anything but green. Considering other possibilities of life encourages creativity while grounding us in scientific pursuit. The discoveries made by the JWST are an important step in paving the way for future exploration missions. For instance, spacecraft designed to probe specific planets within our own solar system, like Europa Clipper for Jupiter's moon Europa, are being informed by what JWST teaches us about planetary atmospheres and habitability. In the coming decades, new missions may aim to visit exoplanets directly, whether by launching star-shade telescopes to further analyze atmospheric data or even creating small interstellar probes to explore nearby star systems. These projects will rely heavily on the groundwork being laid by the James Webb Telescope. Finally, the discoveries JWST has made, and will continue to make, serve as a humbling reminder of how much we have left to learn. If we discover a second Earth, or a truly habitable exoplanet, it will reshape our understanding of humanity's place in the universe. Such a discovery may prompt us to reevaluate everything from space exploration priorities to existential questions about life's universality. Even if we don't yet find definitive signs of extraterrestrial life, the pursuit itself is deeply inspiring. Each image, spectrum, and data point sent back from the JWST fuels public curiosity and reminds us of the limitless potential of human ingenuity. Are we alone in the universe? The James Webb Space Telescope is helping us take leaps closer to answering this age-old question. Through its groundbreaking observations, we've not only discovered new exoplanets, but have also begun exploring what makes a world capable of supporting life. JWST's mission is far from over, and as its data continues to unfold, the possibilities seem as infinite as the cosmos itself. So, stay curious, keep exploring, and never stop looking up. The answers are among the stars.